Welcome to another unit in this exercise set Business Mathematics. This time with an exercise on Lagrange multipliers. So let's have a look at the exercise. Here we have calculate all possible extrema of the function f of x and y under the constraint g of x and y equal to 0. Then we have the function f being the ln of x squared plus y, and we have as the constraint function g as x plus y minus 1. As g is equal to 0, this second constraint actually means x plus y needs to be equal to 1. Okay, if we have to do this, if we in particular see we have a function and a constraint, an equality constraint that is, we know we need to use Lagrange multipliers. This means we simply start by building the Lagrange function. The Lagrange function has a relatively easy, straightforward setup, which is just here the function f plus lambda and then in parentheses the function g. That's basically all there is to the Lagrange function. Due to the fact that we added this lambda here, we added one additional variable to the Lagrange function. So instead of the original x and y, now we have 3, including the lambda. And then we basically proceed as we know this from normal extrema. So we simply take this Lagrange function, get the first derivative, set them equal to 0 and solve this. So if we get the first derivatives here, looks as follows. So it's always, first off, the derivative of f for x, the derivative of f for y, plus lambda times the derivative of g for x, the derivative of g for y. In those cases, it's both parts 1. The third part, this one here, that's actually the function g. So instead of calculating a whole new derivative here, we can just simply copy paste the function g. Okay, so we have the derivatives of the Lagrange function. So what we do next is set them equal to 0. Then we have this system of equations, 3 with 3 variables. So we solve it for those 3 variables. To actually do this, I just copy those 3 equations here to have a bit more space. And well, if you easily want to solve this, you can just follow the idea that in the first step, we take a look whether we can simplify this. Meaning, can we divide any of these equations by x and y to make it simpler? Here, it doesn't really make sense. So at this point, the simplification doesn't actually have to take place. If, however, you were to do a simplification, what you would have to think about is that whenever you divide by a variable, like if you divide by x, you always have to consider the 2 cases. What if x is 0? Consider this part first. And then only if you can exclude the case of x being equal to 0, then you can actually divide by it. So it's basically 2 cases you have to observe. Okay, here, no simplification necessary. So what we do in the next step is get all the expressions with a lambda and only with the lambda as a variable on the right side. So if this were anything else here, you would have to get rid of this as well. However, here we only have plus lambda, so it's relatively easy and straightforward. We can simply solve for lambda, the first and the second one. And there's always the first and the second one. Here, it's simply minus lambda, and the second one is also minus lambda. So at this point, we already see I could now get rid of the minuses if I really solve for for lambda. But I don't have to because it's already the same. And that's even more important. Right side only needs to is allowed to be something with lambda as the only variable, and always has to be the same for both of them, because then we can equalize those two equations, giving us one new equation with only two variables. So in this case, either we can solve this already for one of the variables, or we can simply solve the third one for one of the variables and insert this here. Or if you're really lucky, as in this example, this new one, if you simplify this here by simply multiplying with the denominator of the fractions, already could give you the first part of the solutions. So here, solution already, or first part already reads that x is 1/2. If you already have this, you can insert this then into the remaining third equation. So you would always do this. Even if the x would be dependent on y, you could insert this into the third one. Here, we directly get the solution of a y being equal to 1/2 as well. If you would just have here the x in dependence of y, you might have to solve this for y then, and then reinsert this into the fourth. But this is relatively straightforward in this example. So solve this for the first variable, insert this in the remaining equation, solve this for the second variable, giving us here only a single solution, which is 1/2, 1/2. And well, that already then concludes this exercise. So I hope you enjoyed listening to it. And I say goodbye and see you next time.